Hi, my name is Eric Dillon. I'm the senior instructor at the Johnstone Training Center in Fresno, California. And today we're going to talk about the importance of static pressure. So some of you might be wondering what this is. Hopefully a lot of you do know what it is. This is a Magnehelic gauge. This is kind of the original method that we used to use to read pressures in general, including static pressure in air conditioning and heating duct systems. Obviously we're a little bit beyond that now. We're going to be using an electronic manometer today, and we're going to talk a little bit more about that as we actually get this thing hooked up and do some testing. First, we want to talk a little bit about why we are concerned about static pressure. As most of you know, the duct system is a part of our air conditioning heating system. It's not just a box that makes hot, makes cold. That's what the customers think. The duct system is equally important to the overall operation of the system, and the static pressure that we're going to be testing is kind of an indicator that we use to determine if that duct system is sized correctly and operating correctly. It can give us hints as to blocked ducts, disconnected ducts, and a few other things. But today we're going to go through a few examples of that. We're going to talk a little bit more as we move through this. So the first thing we need to talk about is, of course, the Pitot tube. And it should be pointed out that the Pitot tubes are used for a lot of other things, and Pitot tubes are generally known to be a tube in a tube, and you can tell that by two ways. One, that'll have a little bitty hole at the front, and that's for actually measuring velocity pressure. And that type of tube will also have two connection points. This is just for measuring static pressure in a duct system, and it does not have the hole in the end. And it actually has a little magnet here so that we can clip it onto the sheet metal of whether it be the plenum or the unit or whatever, and they're very convenient. But this is important because this has little holes drilled in the side of it so that we're actually measuring static pressure. And static pressure should be looked at as in like the pressure that would inflate a balloon, right? It's an outward pushing pressure. It's not the speed at which the air is moving, or I know there's a lot of different theories about that, but think of static pressure as the pressure that is expanding a balloon. Okay, it is important when we place these that they face the airstream. There will be those that are going to argue that, and the truth of the matter is, since this is not a tube-and-tube Pitot tube, it really doesn't matter. But because they are actually designed to face the airstream, we're going to go ahead and place ours like that. Okay, so now we've got our Pitot tubes installed, we've got our hoses and everything hooked up to our manometer, and we actually have our manometer powered up. And the one thing we want to make sure on these electronic or these digital manometers, before we turn the system on and start doing our testing, we want to make sure we hit this 0 button and get it zeroed out. As you can see, that it's actually displaying numbers right now and nothing is happening. So we want to make sure we zero it out. And now we're ready to test it. In which case I'm going to go ahead and turn on the fan, and we're going to start to see what the static pressure is doing in this particular system. Okay, so as we can see now, we've got our fan running, so we've actually generating some static pressure, and we actually have some readings on our meter here. And again, I want to reiterate that usually our target is 0.5 total external static. As you can see, this system right here, this is our bottom number, that's our total static. Right now we're reading port 1, and we can switch that to port 2 with this button here. And here is our supply static. It's 0.4. We can switch back. And this is our return static, which is about 0.9 right now. So totaling, they're right in where they're supposed to be at about a ½ inch of static pressure. And one of the things I want to point out is I'm going to reach up here and I'm going to turn a damper off camera, but you're going to get to see this static pressure increase. And so that can kind of give you an idea of what happens when we have an improperly sized duct system, or if we have a collapsed duct, or any numerous problems. Even when the homeowner just closes a register, it can affect this. So I'm going to go ahead and start to close this damper here, and we're going to start to see that static start to rise. See, and we got it up So we're running about 0.6 now. So we're beyond what the unit is actually designed to do. And this becomes really important with modern ECM motors. They're a little more sensitive to it. And so it's very important to make sure that we get within that ½ inch or as close to it as possible. But more importantly, it's doubly important, I should say, that we actually do this test, right? We need to know what's going on, and as you can see, just a little bit of adjustment here can make a little bit of a difference here, but that's going to affect the overall performance. It's slowing down the air, which means our coil might be running a little colder. It can create all kinds of other problems. With that, we just want to go ahead and open this back up, and we'll get this back down, and we're in our happy place again. Okay, so hopefully now you have a little bit better understanding of what static pressure is in a duct system and why it's important to us. For this and any other training needs, please come see us at the JSOG Training Center in Fresno, California, where